He was 63 years old and he had not been sick a single day in his adult life. No prescriptions, no chronic conditions. Just a man named Robert who ate well, walked every morning, and slept 8 hours a night. He was the person at family gatherings who said things like, "I just don't get sick," and meant it. Then the year after he turned 60, something arrived that he didn't have a name for. Not a disease, not a diagnosis, just a heaviness that sleep didn't fix. A fog that sat behind his eyes most afternoons. He started losing his train of thought in conversations he used to own. He told his doctor. His doctor ordered labs. Everything came back normal. "You're 63, his doctor said. "This is just aging." Robert accepted that. Most people do. But Robert had a daughter who happened to be a researcher. And when she came home for the holidays and sat across the dinner table from her father, watching him trail off mid-sentence, push his food around, stare blankly at a conversation he used to drive, she said something quietly that stopped everything. "Dad, when did this start? And did anything change in your diet around that time?" He looked at her. "What does my diet have to do with my brain?" "Everything, it turns out." I'm Dr. Ben, and what I'm about to show you is one of the most important findings in aging science in the last decade. Something that explains, at a biological level, why so many people feel a shift around 60 that nobody warned them about. Why labs come back normal. Why the standard answer is it's just aging, and why in many cases that answer is incomplete. This video has 3 parts. The first will show you what actually changes inside your body at 60 that most doctors aren't yet discussing in routine appointments. The second will show you the research, specific studies, specific findings that explains why it matters for your brain. And the third will give you the only 4 things the current evidence actually supports doing about it. Let's start with a question. Do you know what's living inside your digestive tract right now? Between 38 and 100 trillion microbial cells. Bacteria, primarily, but also fungi, viruses, and other organisms. Together they weigh roughly as much as your brain. They produce compounds your body cannot manufacture on its own. They regulate your immune system. And they communicate with your brain directly through a dedicated neural highway called the vagus nerve, a bidirectional channel that runs from your gut to the base of your skull. Scientists call this the gut-brain axis. And for most of your life, you probably weren't told it existed. When this ecosystem is healthy and diverse, it produces a family of chemical compounds called short-chain fatty acids. But before I tell you what those do, I need to tell you what happens when they disappear, because that's the part that connects to everything you're feeling. A research team recently analyzed gut microbiome data from over 8,000 fecal samples collected from people on 5 different continents, different diets, different genetics, different climates. They built a mathematical model called a gut microbiota age clock, a tool that could read the bacterial composition of a stool sample and predict biological aging. And when they looked at when the sharpest, most consistent disruption occurred, when the microbiome shifted most dramatically across all populations, the answer was the same everywhere, between 56 and 60 years of age. The researchers called it a microbial phase transition, not a gradual decline, a threshold crossing. Core species that had maintained the ecosystem for decades began to fall away. Protective bacteria dropped. Inflammatory species filled the gaps. The whole balance of the gut shifted in a direction that, when you understand the downstream effects, explains a great deal about what happens to how people feel and function after 60. This finding was validated in a separate independent cohort of over 2,000 additional samples. It has since been replicated across multiple research groups. This is not a theory. This is a documented, replicated, cross-continental biological event, and most people going through it have no idea it's happening. So what does it actually set in motion? Here is the chain of events, and I want you to follow each step because each one leads to the next. When the beneficial bacteria in your gut decline, production of a compound called butyrate drops. Butyrate is a short-chain fatty acid, a chemical made when healthy gut bacteria ferment dietary fiber. And it does something no prescription drug currently does as efficiently. It reinforces the lining of your gut wall. Your gut wall is a single cell thick barrier, 1 cell thick. It is the only thing standing between your digestive contents and your bloodstream. When butyrate production falls, that barrier begins to weaken. Tight junction proteins that seal the gaps between cells start to degrade. Bacterial fragments, pieces of cell wall, toxins, inflammatory compounds begin leaking through into circulation. Researchers call this increased intestinal permeability. Most people have heard the more informal term, leaky gut. That term sounds almost manageable. The cascade it triggers is not. When bacterial fragments enter the bloodstream, your immune system treats them as an invasion. It launches a response. That response is systemic inflammation, chronic, low-grade, body-wide immune activation. Not the sharp inflammation of an infection that resolves in days, the slow-burning kind that persists for months and years without ever producing symptom obvious enough to investigate. And that inflammation does not stay in your body. It crosses the blood-brain barrier. Once neuroinflammation takes hold, it activates immune cells in the brain called microglia. Under normal conditions, microglia are the brain's maintenance crew, pruning damaged connections, clearing debris. Under chronic inflammatory conditions, they become overactivated. They begin breaking down healthy neural connections. They interfere with the production of new neurons, and they suppress something called BDNF, brain-derived neurotrophic factor. BDNF is the protein your brain uses to build and maintain neural connections. It is sometimes described as fertilizer for the brain. Without adequate BDNF, the brain loses its ability to repair itself, form new memories, and maintain the density of connections that sustain clear thinking. Low BDNF has been consistently linked in the research literature to cognitive decline, depression, and accelerated neural aging. Now read that chain back in one sentence. Microbial phase transition at 60 butyrate, drops gut barrier weakens, bacterial fragments leak, systemic inflammation, neuroinflammation. Microglia overactivation, BDNF's suppression, cognitive decline. That sequence is not theoretical. A study from the Microbiome and Aging Gut and Brain Consortium, the MyAGB study, examined older adults with mild cognitive impairment alongside cognitively healthy controls of the same age. The adults with cognitive impairment showed measurably higher gut permeability markers in their blood, higher systemic inflammatory proteins, and a disrupted gut microbiome composition. These findings were significantly correlated with reduced performance on standardized cognitive tests. The gut was not a bystander in their cognitive decline. It was part of the mechanism. That sequence begins, in most people, around age 60. Robert's daughter knew this research. She had spent years in it. And sitting across from her father that evening, she recognized the timing. He had turned 60. The labs were normal, because this doesn't show up on a standard blood panel. And something had changed in his diet. He eventually told her. He used to eat plain yogurt every morning. Then around 62, he switched to a protein shake. Simpler, faster. He hadn't given it a second thought. She didn't diagnose him. She's a scientist. She knew one dietary change wasn't a conclusion. But she said, let's start there. And let me show you the study. Because there is a study. A clinical trial conducted at Stanford University, published in the journal Cell, randomly assigned 36 healthy adults to one of two diets for 10 weeks. One group ate a diet rich in fermented foods: yogurt, kefir, kimchi, fermented cottage cheese, kombucha, fermented vegetable drinks. The other group ate a high-fiber diet: legumes, whole grains, nuts, seeds, fruits, and vegetables. The results surprised even the researchers running the trial. The fermented food group showed a measurable increase in gut microbiome diversity. 4 types of immune cells showed less activation. 19 specific inflammatory proteins measured in blood samples decreased. The high-fiber group? None of those 19 inflammatory proteins decreased. Microbiome diversity remained stable. It didn't increase. This is a stunning finding, said Dr. Justin Sonnenberg, the lead researcher from Stanford's Department of Microbiology and Immunology. It provides one of the first examples of how a simple change in diet can reproducibly remodel the microbiota across a cohort of healthy adults. The reason fiber alone didn't do it is important to understand. Fiber feeds the bacteria you already have. If the bacteria are already depleted, if the ecosystem has already crossed the phase transition, fiber has less to work with. You need to reintroduce the organisms first. Fermented foods carry live cultures that appear, based on this evidence, to support that reintroduction. Now I want to show you the people who didn't cross that threshold the same way. When researchers study the gut microbiomes of centenarians, people who have lived to 100 and beyond, they find something that doesn't match The expected pattern. It's not that centenarian gut microbiomes look like the microbiomes of young people. They've changed too. But what centenarians consistently show that most people in their 70s and 80s do not is this high microbial diversity. A broad, complex, resilient ecosystem that still produces the protective compounds a healthy gut needs. A study examining centenarians from Japan and Sardinia found that they had more diverse gut bacteria and viromes than both middle-aged and typical elderly populations. Researchers from the National Institutes of Health observed that many centenarians had a more health-promoting microbiome profile than people decades younger. Something slowed or redirected the crossing of that threshold. The research doesn't give us a single clean answer for why. Diet plays a consistent role. Physical activity matters. Antibiotic use history is significant. Each course of broad-spectrum antibiotics can set the microbial ecosystem back in ways that take months to recover from, and recovery becomes slower with age. And there is growing evidence that microbial diversity has a kind of momentum. The more diverse the ecosystem remains, the better it resists disruption. Centenarians across cultures tend to eat real food. They tend to move. They tend to have lower lifetime antibiotic exposure. And they tend to consume fermented foods, not as a supplement strategy, but simply as part of what they've always eaten. None of that is a guarantee, but all of it is instructive. So here is what the evidence actually supports doing. 4 things, in order of the evidence behind them. The first is to add one fermented food to your daily routine. 1. Not a supplement, an actual fermented food with live active cultures. Plain yogurt, kefir, kimchi, sauerkraut, miso. The Stanford trial showed measurable changes in 10 weeks. That is not a long commitment. The goal is consistent daily exposure to live cultures, not large quantities, but reliable frequency. The second is to feed what you're rebuilding. Once you've begun reintroducing diversity, fiber matters, specifically prebiotic fiber, the kind that beneficial bacteria ferment into butyrate. The richest sources are garlic, onions, leeks, asparagus, Jerusalem artichokes, slightly underripe bananas, and oats. These are ordinary foods. The gap is usually not knowledge, it's consistency. The third is to treat antibiotic courses as gut events, not just infection treatments. When antibiotics are necessary, take them always. But ask your doctor whether a probiotic is appropriate to take alongside or immediately after. And plan to actively rebuild diversity through fermented foods in the 6 to 8 weeks that follow. The recovery doesn't happen automatically at 60 the way it might have at 30. The fourth is the conversation to initiate at your next appointment. Write this down, because the phrasing matters. I've been reading about the gut microbiome changes that occur around age 60 and their links to systemic inflammation and cognitive health. Can you refer me to a gastroenterologist for a microbiome assessment? Or tell me what markers you'd look at to evaluate my gut barrier health? That question is specific enough that a physician cannot answer it with "it's just aging." It signals that you have done your reading. It asks for a referral or a test, not a reassurance. Most primary care doctors are not yet proactively raising this. But a gastroenterologist who follows his research will engage with it immediately. Robert made one change. He put a small container of plain kefir back in the refrigerator. He started eating garlic again, cooked into food, smaller amounts. He started walking after dinner instead of sitting. His daughter didn't promise him anything. She told him what the research suggests, not what it guarantees. She reminded him that his experience would be one data point, not a study. But 3 months later, he called her. He said the fog was thinner. He was sleeping more soundly. He'd finished a book, actually finished one, end to end, for the first time in over a year. She was careful with her response. "I'm glad, Dad. Keep going, and keep your next appointment." That carefulness is the right instinct. One person's experience is not evidence. What is evidence is the sequence. The phase transition at 60, the downstream inflammation, the connection to cognition, and the demonstrated capacity of simple, consistent dietary choices to begin reversing some of what shifts. The science is not complete. Research in this area is moving fast, and some of what we know will be refined. But the direction of the evidence is clear, and the actions it points toward are low risk, accessible, and grounded in real data. Around age 60, something changes in the gut that most people have never been told about. It sets off a chain that reaches all the way to the brain. And unlike many of the things that change with age, this one responds measurably to what you eat. Now, in the next video, I'm going to bring both threads of this series together. We've covered what's in your medicine cabinet. We've covered what's happening in your gut, but there is a third system that governs the timing of both of them. And when it breaks down after 60, it makes everything else harder to fix. It's your body clock. The research on what happens to it after 60 is some of the most surprising I've come across, and one study in particular, following nearly 3,000 people for over 20 years, found something about daily meal timing that changes how you think about when you eat, not just what. Subscribe so you don't miss it. And if you know someone in their 60s who has been told their brain fog and fatigue are just aging, share this with them. The answer might not be simpler than anyone told them, but it might be more available. I'm Dr. Ben. I'll see you in the next one. The information in this video is for educational purposes only and does not constitute medical advice. Always consult your doctor or a qualified healthcare professional before making any changes to your diet, medications, or health routine.